Hello class, welcome to our lesson today dealing with testing claims about the mean, but sigma, the standard deviation of the population, is unknown. We're going to go through 3 example questions about going through the entire process of looking at a claim. I'm focusing on using the t-distribution table that you've been given from your textbook. You can also make sure that you use StatCrunch to find the actual p-value. That could help you be successful on some of these questions. You need to be comfortable with both the p-value ideas from StatCrunch and also how to find the p-value kind of range of answers using your t-distribution table. This question says a sample of 106 body temperatures, that's N, had a mean of 98.2 degrees Fahrenheit. That's X bar, the sample mean, and a standard deviation of 0.62, which is S, the sample standard deviation. Use a significance level of 5% or 0.05 to test the claim that the mean body temperature is equal to 98.6. That means my null hypothesis is the mean equals 98.6. The alternative would be not equal to 98.6 with an alpha level of 0.05. I take X bar 98.2 minus the mean that I am testing, which is 98.6 from the null hypothesis, divided by S over root N, 0.62 divided by root 106, and I get a test statistic of negative 6.64. Remember, this is a two-sided test, so I have negative 6.64 and positive 6.64. When I go to my table in my t-distribution, if I look for the test statistic of 6.64, that's going to be a value on a two-sided less than 0.01 because that test statistic is even further to the left with the degrees of freedom of 100 because 105 is our actual degrees of freedom, but I can't really find that number. If you're asked to use the table, you have to show that you understand with this idea. If you have to find the p-value, you can use StatCrunch to be able to find that with a t-test, and that would probably give you a more precise answer. Either way, you will reject the null hypothesis because your p-value is less than alpha. We reject the null. Now, I'm using a little bit different wording than I have in the past to help correlate some things to your textbook. Your homework goes through some of these questions, and when it's an equal to, not equal to, they show that there's significant evidence to warrant rejection of the given claim, which is the null hypothesis. They do that because when we claim that it's equal to 98.6, we're trying to see if it differs from that. So in the past, I've said there's sufficient evidence to support the claim that the temperature differs from 98.6, which is all this is saying. That's supporting the alternative. We're also warning rejection that it does equal 98.6, which is okay in this case because the alternative is not equal to. You couldn't use this aspect of your conclusion if the alternative was a less than or greater than. You have to say something about that in your conclusion. When you're asked to test a claim, all of these things should be included. Null alternative hypothesis, test statistic, p-value, possibly a critical value if needed, reject or fail to reject the null, and then a written statement about this particular conclusion in context. The next one is about voltage amounts. According to the manufacturer, normal voltage output should be 120. We're trying to test the claim that it equals 120, so this question is almost the same as the last one. Instead of 98.6, it's 120 for the volts. 40 measured voltage amounts, that's N, have a sample of 123.59, which is X bar, and a standard deviation of 0.31, which is S. I plug into the test statistic formula, X bar minus the mean, divided by standard deviation over root N. I get a huge number here, 73.24. Huge, huge, huge. This is going to be a really small p-value. Using my table, I know I've got 73.24 and negative 73.24. That's definitely going to be a p-value less than 0.01 for a two-sided test. In fact, it's much, much smaller if you actually find the p-value. I reject the claim, and then I wrote the other version. There is sufficient evidence to support the claim that the voltage amount differs from 120. You could also write it similar to this last one. You could say it warrants rejection of the claim that it does equal 120. Both of those would be correct in a equal to, not equal to situation. The next one has a lot of information here, but this is about how much lead is in the air. Okay, so the measurements were taken by one of the buildings at the World Trade Center site after 9/11 occurred. So with the collapse of the buildings, there was some considerable issues and concerns about air quality, which is still showing its ramifications today. Use a 5% significance level to see if the population has a mean greater than the standard of 1.5 micrograms per meters cubed, and this is just the units that are being used. So when we're looking at that, my null hypothesis is always equal to, and then my alternative hypothesis is greater than, because I'm trying to see if it is greater than 1.5. The difference with this question is they only give you a set of data. You have to find the mean and standard deviation then. You can use summary stats columns from StatCrunch or some type of utility with technology. You'll have to find that the mean is 1.538 and the standard deviation is 1.914. You're going to have to find those numbers yourself off to the side somewhere. You should not be doing it by hand to find that answer. It's plug it in with technology to find the standard deviation. From there, I take my mean, which is the 1.538, minus the mu population mean that I think it should be, which is 1.5, and then divide by the standard deviation I found over root 6. I get a test statistic of 0.0486, and this is a greater than situation. So if I have an area to the right, if I use the p-value idea with degrees of freedom of 5, my p-value is way too high. Okay, it's much higher than 0.1, which is definitely higher than my significance level. I would fail to reject the null hypothesis in this case, which means there's not sufficient evidence to support the alternative claim that the mean amount of lead in the air is greater than 1.5. There is a little bit of an issue here with the idea of the central limit theorem, because we don't know if this information is necessarily a standard normal curve. While we came up with this conclusion, we may not have been able to say that because our sample size was so small. Remember, according to the central limit theorem, our data needs to be from a standard normal situation, bell-shaped curve, or it has to be at least n equals 30. So when we're looking at those situations, this may not be a valid conclusion. So just because we got a p-value that was really high with a really small test statistic close to 0, doesn't mean that it's going to end up being that way long term. Those are some things that you want to think about as you're going through your test statistic questions. Just a reminder, make sure when you test a claim, it's going through this whole process. On our last kind of assignments and assessments, some people were missing bits and pieces of this as they came up with their conclusion. Let's try to do a better job with the mean questions about going through the entirety of the claim as opposed to just some of them as we go through those different situations. Have a good day, everyone.